Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss logarithm. Good number of questions from logarithm and its properties are frequently asked in competitive examinations. The topic is really easy. Even problems based on logarithms are very easy. You need some practice and you should be clear about the basic properties of logarithm. That's it. Friends, actually logarithm makes the calculation, the arithmetic calculations very easy, right? See what happens, all the multiplications are converted to addition and all the subtractions are converted to division in case of, all the divisions are converted to subtraction in case of logarithm. So the calculation becomes very easy, right? See, in the case of logarithm, while we calculate, while we have to make the calculations, the base of the logarithm is generally used as 10, right? But in general, the base of logarithm can be any number, right? So all that we are going to discuss in this topic, in this session, okay? So let's begin with that. First of all, we are going to discuss what are the different terms in logarithm. See, suppose a raised to b is equal to say c, right? So how do we write this expression in the case of logarithm? That's log a c is b. And how do we read that? Log c to the base a is b, right? Suppose 2 cube is equal to 8. Then how do we write it in logarithm? Log 8 to the base 2 is 3, right? So this is actually base of the logarithm. This is index and this is the value of log 8 to the base 2, right? So this is base, this is index. Log 8 to the base 2 is 3. Similarly, 3 raised to 4 is 81. So log 81 to the base 3 is 4, right? So this is how we read, we write or we take the logarithm of any this equality, okay? Now the important points that you have to keep in your mind, I write it over there, very important. As I have talked to you regarding this base, right? This base can be any number, but it cannot be base of the logarithm. It should not be negative. The first thing, it should not be 0. The second thing, okay? So the base of the logarithm cannot be negative and it cannot be 0. That's very important, right? Base, okay? That means this term, suppose it is log b to the base a should be greater than 0, okay? A should be greater than 0. For the values less than or equal to 0, the base is not at all defined, or we can say logarithm is in fact itself not at all defined, right? Next thing, this value, that is this index, cannot be even negative, right? So logarithm is defined only for the positive values, right? That means I write it over here. Suppose we have log say a to the base b, so a should be greater than 0, right? It should not be negative, neither 0 nor negative. And the third important thing, we have just discussed that base of logarithm should not be negative, it should not be 0, simultaneously it should not be 1, right? So a should be greater than 0 and a should not be equal to 1, right? So base cannot be negative, 0 or 1, right? But index can be 1, a can be 1, right? So the two things are clear in your mind. Base, that's b, it's not equal to 0, it's not negative, it's not 1. And index is a is not equal to 0, it's not negative. It can be 1 but it's not 0 or negative. So these are the important points to be kept in your mind, okay? Now here we take the properties of logarithm one by one, right? Log of a into b is log of a plus log of b. Here a, b, that means a into b, right? Now the common mistake which student make is log of a plus b. They write log of a plus log of b, right? So this is actually a blunder. Don't do this. This is not at all true. It's wrong, right? In fact, log of a into b is actually log of a plus log of b, right? So if you write log of a plus b also as log of a plus log of b, that means log of a plus b is equal to log of ab, right? So how a plus b can be equal to ab? It's not necessary always, right? Okay, so be very careful about it. Do not make this blunder, this mistake, right? The next thing, log of a by b, when a is divided by b, so that is actually log of a minus log of b. So again, do not write log of a minus b as log of a minus log b. The same logic is over there also, right? The third thing, log of a raised to m can be written as m of log a. And log a to the base a, when base and index is same, the value of the logarithm is 1. In all the cases, as I've already discussed, a and b, both of them are positive quantities, right? Base, if it is not written, we consider in the calculus, we consider the base as exponential, that's e, and in arithmetic calculation, if no base is given, we consider it as to be 10, right? So it is always not necessary to put up the base of the logarithm. Okay, if nothing is given, you can assume it to be e or 10. In arithmetic calculation, assume it to be 10. In calculus problem, assume it to be e, right? So yeah, clear? A and b, both the logarithm, we are taking logarithm of a and b, and both of them should be positive quantities, right? A by b, log of a minus log b, a raised to m log a to the base a, that's 1, right? Now this case, the next property, log a raised to n to the base b raised to m is actually n by m log a to the base b, right? So this is also the property of logarithm. I put up an example. Suppose the base is 2 cube and index is 3 raised to 4. So that can be written as, or I just write 3 raised to 5 to avoid confusion. All the numbers are different from each other, or I write say 7 raised to 5, okay? So all the numbers are different from each other. So that's 5 by 3 log 7 to the base 2, right? B, M, A, N. So N by M, that is this by this by this, and log A to the base B, that's log 7 to the base 2, right? So this is how we can write it. Okay, so that's important. Frequently it is used, this property is used frequently, I mean to say. Now log a to the base b, here the base is b, and if you wish to change the base, it will be 1 upon log b to the base a, right? Suppose log say 8 to the base 2, it's actually log 2 to the base 8, precisely 1 upon this. Okay, so when you wish to interchange the base and index, 1 upon the same. Okay, so log a to the base b is equal to 1 upon log b to the base a, precisely log a to the base b into log b to the base a is 1. Okay, here log a to the base b and a new base m is introduced. So in that case, log a to the base b will be log a to the base m divided by log b to the base m, right? So suppose I have log say this, right? So this is actually log 3 by log 2, and this base is maybe any other number, maybe say e, whatever, right? So this way you can change the base of the logarithm. Okay, so these properties we will be using while solving the problems. Now the next property, a raised to log m to the base a is actually m, right? So how do we establish this property? I assume I take this log a raised to m, I assume it to be k, right? That means a raised to k is equal to m, right? Now a, this is what? K, a raised to k is m. So this is how we can establish this property. Okay, So that a raised to log m to the base a will be m only. That means if this and this is same, your answer will be this. Okay. Similarly, this a raised to log b to the base e will be b raised to log a to the base e, right? So this you have to keep in your mind. And here log 1 to the any base is 0, right? So log 1 is will be always 0 irrespective of the value of the base. Okay. And why it is happening? Because any number raised to 0 is 1, whether x raised to 0, whether y raised to 0, whatever, right? So if I take logarithm, what I'll do, log 1 y, that's 0, right? So doesn't matter what this quantity is, log 1 will always be, I'm sorry, log this y is 0, right? Doesn't matter what whatever the base is, it will always be 0. Now friends, as discussed, logarithm of this negative quantity and 0 is not at all defined, but value of logarithm can be 0, can be 1, or can be any negative number, can be a negative number, right? Now what are the conditions? Listen to me carefully. Suppose I have the base of the logarithm as 10, right? So log 10 2 will be a positive quantity, okay, and it will be greater than 0 but less than 1, right? Suppose this is, I say it's x, so x will be greater than 0 but it will be less than 1, right? Similarly, log 10 to the base 10 is 1. And the third thing, log 10 to the base that's greater than 10 may be any number, say 11 or say 12, 15, whatever, that will be x will be greater than 1, right? So you see the difference here, here, here. If this value is smaller than the base, this value, the index is smaller than the base, then the logarithm will be positive, but it will be less than 1, right? This, okay. If base and index are same, then the value will be 1. If index is more than the base or greater than the base, then the value of logarithm will be greater than 1, right? So you need to keep all these things in your mind. The next is, suppose I have any fraction over there. Suppose log 10, I have the fraction say 1 by 5, right? So value of this will be less than 0. How it is, I just show you. Log 10 1 by 5. I calculate it for you, or say 1 by 100, right? So that will be log 10 to the base log 1 to the base 10 minus log, see log a by b is what? Log of a minus log of b, right? So log b is 100 over here, okay. Now log 1 is this 0, doesn't matter whatever the base is, minus this 100 is what? 10 square, right? So log 10 10 square, so that's 2 log 10 to the base 10, so that's actually 1, so it's minus 2, right? So this value is 2 and minus we are having over here, so precisely it is minus 2. That means if index is a fraction, that means a quantity less than 1, then the value of logarithm will be negative. Okay, so these are very important properties of logarithm that you have to keep in your mind. You can do some of experiments on your own. Okay. I just take some examples to calculate the values of logarithm. Suppose 3 raised to 4 is 81. I write it as log 81 to the base 3 is 4, right? Similarly, if I take see 81 raised to 1 by 4 is 3, right? So log, right? Now this and this, if you multiply both of them log 81 to the base 3 and log 3 to the base 81, right? Log 81 to the base of 3 and log, it will be 4 into 1 by 4, that's 1, right? So log a to the base b into log b to the base a, that will be 1, right? Similarly, if you wish to calculate log 3, say 1 by 81, that's what, right? I suppose it to be x. As I told you, if it is a fraction, the value of logarithm will be negative. That means x will be negative. Now let's calculate that. I assume log 3 to the log 1 by 81 to the base 3 to be x. That means 3 raised to x is equal to 1 by 81, right? So 3 raised to x is equal to 3 raised to minus 4. That means x is equal to minus 4, right? So log 1 by 81 to the base 3 will be minus 4. That is negative value, right? So this is how you can practice some of the questions. Okay. Next is logarithm equalities and inequalities. Suppose log a to the base b is equal to log c to the base b, then a is equal to c, right? If not equal, then there will be two cases like this. Log x to the base m is greater than log y to the base m. In that case, x is greater than y if m is greater than 1, and x will be less than y if m is between 0 to 1. That means m is a fraction. Okay, that's less than 1. So this is also an important property that you have to keep in your mind. Log a to the base m is greater than b. That means a is greater than m to the base b, m to the power b if m is greater than 1, and the second, if m lies between 0 to 1, then a will be less than m raised to b. So just write these property to 3 times, take some examples. So these properties will be like set in your mind. The third thing is this. Okay. So we have discussed almost all the properties of logarithm, the basic properties, the properties of inequalities and all that, right? So you should revise this session at least 2 times, so all the properties of logarithm should be clear in your mind, right? In the next session, we'll be taking problems based on logarithm and its properties. Okay. So bye-bye. I'll see you in the next session once again.